Okay. The YouTube stream should be up. Maybe somebody can check the audio over there really quick. But aside from, but I do see the little audio bar doing stuff. So I think I got it right this time. Although haven't seen anybody type anything in the chat here, so maybe somebody can type something and make sure this can. Okay, excellent. Thank you. Let me share my screen in here so you guys can see this too. Let's see, this screen. And okay. So now we should have the video on in Discord as well. All right. So today, so I've got two Discord servers. I've got one that's specifically for the C# Player's Guide. It's a lot more active than the other one. The other one is like a game development one. It's kind of interesting though. Like that's actually the C# Player's Guide is like the that was kind of a spin-off. I have these tutorials here. And so this was like, it started as XNA. There's a long history here. I've been trying to port them over to MonoGame. It's like mostly the same stuff. But anyway, so in my other server, which if you rbwhitaker.wikidot.com, there, if you want to join this other server, you come in here to my wiki here and go to this chat Discord. This is old enough that we used to use IRC back in the day. And anyway, you can just go on here and that's the link that'll get you in there. So you can join that if you aren't on there but are interested in like what we're talking about here today, because like a lot of that server is about, it's not like meant to be specifically about MonoGame, but it tends to be mostly that because that's what I'm most familiar with. It is also not nearly as big as the C# one, and I'm okay with it. Not that the C# one's all that big either. But anyway, so I had somebody over there asking a question of like they're trying to get their drawing right. They've had some issues trying to get they're trying to use an orthographic projection to do a, what's that called, like an isometric view for a game, and they're trying to like make sure that everything's like looking right. And they brought up this question that was kind of just a casual comment, like how would I go about like drawing coordinate axes on there so I can just kind of do a sanity check, because they're having some issues with like the models they're drawing looking a little weird or whatever. And I thought, oh, so I kind of like pointed them out. I was gonna bring this back over here. The pathway that I'm going to go down, I haven't ported these over, although there's nothing that I'm aware of that wouldn't work here, but it's these primitives tutorials. So I kind of pointed this person down this path, but then I got thinking about it and I thought this would be a fun thing to tinker with today. So that's what I'm planning on doing, is just kind of going in here and exploring this. I've done this exact thing before where you just want like a red line along the x-axis, a green line along the y-axis, and a blue line along the z-axis. That's all we're going for here today. So this might be kind of like boring, but I think that just kind of messing around with MonoGame is still going to be sort of an interesting thing to explore. Unless I don't even have MonoGame installed, then I'll have to install that and it'll be games. Oh. This computer is relatively new, and I may just have not installed MonoGame yet. All right, let's go get it. Let's see. Where's the download? I'm just going to be winging this here. We'll see how good their documentation is. With as much as I've used MonoGame, you still don't install it that often. Okay, I've already got .NET 8. I don't need to do that. I wonder if they're just saying here, just do... See, that's the thing is I don't need any of that either. Done. I mean, the alternative may be to switch to a different computer really quick that's already got it on there. I don't need anything. I don't need any of that stuff. I don't need this either, but I feel like understanding the code feels like it's already gotten ahead of what I need. What I need is a template. And so, I mean, the other... I wish I had checked this before I started doing the stream, but here we are. Maybe I'll follow my own tutorial. See, this right here is what I'm looking for. So what I need is the previous tutorial. Already got Visual Studio installed, so install the MonoGame. And where's Visual Studio? Here we go. Back, continue without code. What did this say? Extensions, manage extensions. MonoGame. There we go. Well, whoever wrote that tutorial, they're my hero. Okay, let's try this again. So now, file, new project. Now let's see if we've got MonoGame in here. No. Oh, I don't think I'm done. Hang on, I'm getting ahead of myself. It says cancel, cancel install. Oh, okay. Apparently got to restart Visual Studio. That's okay. Did it. I'm not sure that did what I thought it would do. I don't think I need this. So you just need templates. It's not like a Visual Studio like component. Let's try this again. Tools. Extensions. Manage extensions. Oh, you know what? Okay, I have a theory about what happened here, and it is the modifications will begin when Visual Studio is closed. I did close this window, but I got a bunch of other windows here, so I'm probably going to have to close all of it. So let's close that. And oh, well now it's actually, this time it feels like it's trying. Modify. This is a fun side quest I wasn't expecting to be doing right now. Do I dare just tell it to close all those? Oh, okay. It was, okay, we're good. Comment in YouTube. Can you get the templates from inside Visual Studio extensions? That's what I ended up doing. I just had forgotten that that's where you look. So I didn't see that comment until just now, or I might have said something about it sooner. That might have helped, but... All right, let's try this again. Create a new project. Hopefully this time. There we go. New. Let's see. I will typically pick this one, cross-platform desktop application. Like, unless I know what I'm doing, like this is a pretty good like default for just whatever. Like, unless I'm going for specifically Android or something else, a library. Like, this creates an actual game, and it's cross-platform. So like this will use OpenGL rather than DirectX. Not that you can't change it later, but anyway, that right there is what I want. So I definitely don't want it there. Pick a different location. Let's put it here. Wait, what? All right. So I don't mean for this to be like a MonoGame crash course. Like, I don't really want to like explain everything that's in here. There's not much code here, right? Like, this is just what you get straight out of the box, and we just need to add in our coordinate axes. The basic idea, though, is, like I said, I'm going to use this thing, like those tutorials that I linked to. It deals with this stuff called primitives, which is like drawing. Like, it's this idea of like, I'm going to just give you a bunch of triangles or lines or whatever to draw. And the thing about that is, it sounds low level, but that's the currency of the graphics card. That's what it does. And MonoGame has like a model class, and we could create a little like model of like some coordinate axes, have little like arrowheads and like whatever it is. Like, you could make something like that that's fancier, and if you wanted to show it to like a user, it would make sense to make a model and import it. And there is a model class that does a lot of this for you, with the caveat that in MonoGame is an open source port basically of XNA, and the creators of XNA debated long and hard about, should we have a model class at all, because there's a lot of ways that you can represent stuff that you want to draw on the screen. There isn't one way to do it. Different games have different needs, and XNA, the creators of XNA, didn't want to pigeonhole you into, this is the way you're expected to do it, this is the way you're supposed to do it. So they debated whether they should just say, look, we're not gonna give you anything. We're just gonna let you, import your stuff and just figure it out. We'll give you some tutorials, so that you can get whatever data your 3D models need. Do you need colors? Do you need textures? Do you need multiple texture coordinates? Do you need like transparency in your textures? Do you need like all this stuff? Like, what exactly do you need? What data do you need? It varies significantly from game to game. And XNA, and therefore MonoGame, said, we're not going to be opinionated about this. We want to give you the tools to do whatever you think your game needs. But then they said, yes, but people are going to open this up and be like, well, now what do I do? It's too hard. I don't know where to even begin. So they, after a lot of debate, they finally said, fine, let's make a basic model class, and then make it so we can just import those. And it's going to have, we're going to cover some useful ground here. It's going to be good for getting started. It might be good for crossing the finish line with certain types of games, while also giving people the tools to like not do that, but to like load their own vertex data, their own like mesh data separately, and just make their 3D stuff that way. essentially that's what we're doing here. We don't need anything too fancy. We just need to create the data and then draw the data using the basic fundamental tools that exist in OpenGL and DirectX. And like this is just how this stuff is typically done. It's just in a lot of MonoGame stuff, it's convenient to have this model class that we can just, content.load some model, name the file, and then poof, you got your thing there. Even though that's not necessarily meant to be like a completionist model object. Like you might create your own depending on what you're doing. It doesn't really help us here. So we're not going to do it that way. What I'll do is I'm going to come down here and I'm going to, so just kind of starting at the beginning, and this is probably, I'll just start really simple. So what we need to get going is we need a vertex buffer that stores our vertex data, and then we need to get that shipped over to the graphics card basically. So what I'll do, there are a bunch of types in here that are like pre-made, and again the intent is that you're supposed to create your own of these. But I think vertex, let's see, we need position and we need color. So you can see like vertex, position, color, but there's also vertex, position, color, texture. So like if you wanted something like this that also had texture coordinates, or that had a normal, or that had all of those, I think there's also vertex, like vertex, texture, let's see, vertex, position, normal, texture. Like a lot of stuff will just be this guy. Because a lot of times you don't need the color. You like that you have color, but it's coming out of the textures that you're using instead of having the vertex actually have a color. But so vertex, position, color, that is that, like I'm gonna make an array of those, and this is a struct, so it is a value type. And that means that when I allocate an array of these, like all the data just lives right there back to back to back. Like if I make, let's see, we're going to want 6 of these. Actually, well, new vertex, position, color. We're going to want 6 of these because we're drawing 3 lines. Each of them has an endpoint. But again, like this data ends up being back to back to back, all packed in, which is exactly what we want for sending this to the graphics card. We want to be able to just take all those bytes and just hand them off straight to the graphics card. So in here, we'll say new vertex, position, color, and we'll do new vector 3. So actually what we can do is vector 3.0 and then vector 3.unit x. These are convenient, like, did that not work? Unit. I'm getting ahead of myself. I need a color. So color dot, let's say red. So it's, again, like you don't have to use these colors. You can always just make a new color. But there. This is, so I have my first point is at 0, 0, 0 in 3D space. It's right at the origin, and its color associated with that vertex is red. And then my next point here is one unit along the x-axis. So it's not like this is it's 1. It's not very far out there. We might want to scale that up. And then we'll do, I'm gonna tweak my white space here so it's a little easier for me to understand. But then we'll do green for the y-axis and we'll do blue for the z-axis. And this is, let's see, what is this telling me? It's saying I can leave off the class name. I actually think I'm gonna do that. I think I'm gonna delete that. And that's telling me it's unused. Yeah, I'm going to use it here in a second. All right, so like that's all the data we need. So like you can see, like there, it's just got a bunch of bytes that have just been shoved into this big array. And then we need to create a vertex buffer. So vertex buffer equals new vertex buffer. And we have to give it a reference to the graphics device, which is a thing that the game makes for us. It has a reference to, so I can just pass that in. And then it wants to know the type being used. So it's type of vertex position color. And that's so that it can understand. Like I think the main thing here, I think we could go look at this. Maybe go to it's this iVertex type vertex declaration. Like this has the metadata that if you're building this yourself that you would create, and to have this, to tell it like what data lives at which bytes within this array for each thing. So if you're building your own, you have to do this. Since we're using an existing one, we don't have to do that, which is great. So new vertex position color, and then what else do we need here? So vertex count, we'll pass in a 6 because there's 6 of them. And then buffer usage, this is an enumeration, buffer usage dot none or write only. This is, we'll call that write only. We are going to set the value to it, but we're not, for example, we don't need to do anything fancy with it. So now vertex buffer dot set data, it's already suggesting exactly what I want. Thanks for the assist. So now we just put that in there. And now the other thing, so you can just draw a vertex buffer. And I'm debating whether I should just do that. This might set me up for success a little better if I just make an index buffer. So the idea so I can do that, and I could just say, here's this, draw 6 of them. I'm going to draw 3 lines is what I'm going to do. But, so draw 3 lines. But what I think I want to do is you can have an index buffer that, so you imagine a 3D model, it's got a mesh, and there's all these triangles in there. You're going to have a lot of times where the points are shared. And rather than have and I think, and like a kind of decent example of this is like, I'm using 0 for the starting point of every one of these. Like one thing I could do to save on the amount of data I send to and store on the graphics card would be to just use a single origin point. The problem is I want different colors for those. So because I want to like differentiate the green line, like what I could do is I could say we're going to make the origin white, and then I'll just remove this and I'll remove this, and now I'll just basically draw, like I have all the points that I need. I just need to be able to create line segments from 0 to unit X, from 0 to unit Y, from 0 to unit Z. But given that I don't want them, like that would create line segments that fade from white to red and then white to green and white to blue, which actually might look pretty nice. It might work well. Like maybe that's what you want. In this case, I think I want like the whole line to be red, the whole line to be green, the whole line to be blue. But I think I'm going to go ahead and make an index buffer anyway. And so what I'll do here is I'm going to make an index buffer, even though it's going to be kind of boring, but so new short, and I'm using short just because I know I'm not going to get anywhere near the upper bound of a short is it's like 32,000 ish. I have 6. So I know I'm not going to like overflow a short. So, and I've said this a lot of times in the Discord server about like choosing types. Like int it follows the Goldilocks principle. It's usually not too big, not too small. It's just right. That's how most C# programmers think is I'm going to just default to int. I'm just going to pick int, roll with it, and unless there's some compelling need otherwise. I think that this is a space where you could argue we're there, other than we only have 6 points. If you have more complex model data, but your objects never have more than 32,000 points, then you're going to cut out like this array. If there's 32,000 points or even 10,000 points, but you're drawing all these triangles like that, it can definitely add up. And so this is one of those cases where it could make sense to use short anyway. And so I'm going to use short, but this is going to be really boring. Which is why I debated whether I actually need an index buffer. But the idea would be, going back to what I had in here earlier, like if I were going to do this and just like reuse the origin point here, then what I do is I would say, well, okay, the first data is going to be from, like, I define all my points, and then I'll say 0 to 1, and then my next line segment is 0 to 2, and then my next one is 0 to 3. So I get my one from here to here, here to here, and here to this one. In this case, I didn't do it that way, so like I said, it's kind of boring. In theory, I don't need this. It's just kind of overkill, but I'm doing it anyway because, well, here we are. Maybe I'll regret it later, but... So same type of stuff here. We need to give it the graphics device, and we need to give it the... There's 2 overloads here. Yeah, type of short. So we need to be clear to it about like what this stuff is. And we have 6 indices, although I think I'm going to use I think this is probably a little more resilient to use indices.length, so that if we do add or remove, I don't have to modify that code. And then same here, buffer usage dot write only, and index buffer dot set data indices. Okay, so theoretically, I've got what I need there in terms of the raw data. Now I'm already in my draw method, and unfortunately the way I've got this set up means I'm gonna hit this code every time I draw. Creating these buffers and sending the data to the graphics card is not cheap. It'd be better for me to not do this every time. I'm gonna leave it this way for a moment, but like in theory, like I'd make these like fields somewhere else, initialize them once, and that's all I need. I'm gonna leave it this way just for a second. We're just gonna see if we get what we expected. The other thing I need is I need an effect. Effects are kind of the accumulation of all of the... It's like... I don't know how much to get into on this. I'm going to do it, because why not? Once upon a time, graphics cards it was called a fixed function pipeline. There was like... Everything that you drew fit into a very specific scheme, and you as the programmer could tweak parameters. Like you could, like there was this expectation that you'd have color and texture coordinates, and then you could say, okay, here's the color data, and here's the texture to use, and like you could like set parameters and tweak it a little bit, but like it was like the options were limited. You could only do what the graphics card was capable of, and they started, like, the people who made graphics cards and, like, graphics libraries like OpenGL and DirectX, more and more started saying, people want all these options. Like, they want this and they want that. And, like, does it really make sense for us to keep adding in all these possibilities and variations? Like, no, but we also don't want to limit people on what they can do. And so they said, what we're going to do is we're going to give programmers the ability to write little teeny programs that get shipped over to the graphics card, and we will run your little teeny program on every vertex and on every pixel that we draw on the screen. Obviously, that can't, like, you can't send C# code to the graphics card. So they use a specific language. These are called shader languages, and the whole like it's code that is meant to decide. Basically, I mean, it's called shader because like it ultimately like it originally came from like lighting. Like, how do you want to like handle the lighting? But like even though a lot of the code that goes into this isn't about lighting anymore, it's about a lot of other concerns. They're called shaders for that reason. So you'll write like a pixel shader, or you write a vertex shader, and an effect is like this accumulation of all these shaders, and like you can like do multiple passes. Like there's a lot going on here, and I don't want to get into it too much. But MonoGame and XNA have this effect that's basic effect. That kind of has some basic things in there, and like when you say load this model, it'll automatically create an instance of basic effect. You always have the option to go write your own shaders, but again, this is just at least now when I open up the box, I have something interesting to play with, even if I know I'm eventually going to write my own shader, and that's useful. So I need this. I need a basic effect. I'm trying to remember how. Because I feel like, okay, so I just need the graphics device, which I have. Again, I don't actually want to create a new one of these every single time in the draw method. That's not cheap. I want to just create it once and call it a day. But I think that's enough. So this has a bunch of like, if we basic effect, it's interesting to this has like a bunch of techniques. I think there's like 16 techniques in this, so it actually is a very and it has a lot of smarts to like decide which technique to use depending on settings and whatever. But all right, what I might need to do something else here, but what I need to do is this graphics device dot draw index primitives. I think this draw index primitives, and then here it has primitive type dot line list. So if we use line list, like that's what we've got. We got just a sequence of lines in here, and the other options, like in most cases, the most common one would probably be triangle list. Like most of the time, you'd use that. But so like triangle strip, like that's the line strip is easier to understand, so I'll deal with that. Triangle strip works in a similar way, but so like a line list, it's like I'm going to give you the first point, and then I'm going to give you the next point, but then I'm not going to like repeat that point again. If I want to make like a polygon or a polyline, and I want to like connect 8 points in with a bunch of line segments. Line strip would allow you to just say starting point and then the ending point of that first segment, and then just immediately go to the ending point of the next segment, and then the ending point of the next segment. In our case, like we do go back to the beginning. Like we are our data here. The way we set this up is like I really have just 3 completely independent, disconnected lines. Therefore, I want line list. But if you wanted to have like a chain of lines, then line strip is more efficient because you don't need as many indices. Triangle strip is kind of the same, where you can just like, basically you get the first 2 triangles going, and then you can just every new triangle adds another, or is it every 2? Anyway, I don't remember the details, but so yeah, in this case we want line list, where it's just a list of lines, and then what does this need? So base vertex. So this is like, well, what are you like? This allows you to like have multiple like data in here that's like modified somehow. So there's a lot of these parameters that give you control, but like a lot of times you'll just pass in 0. So the base vertex is index 0. So I'm saying start here, and then my start index is also going to be 0. So start here, and then my last parameter there is primitive count. So I need to draw 3 line segments. And I think the one thing I need here is I need a, so for each effect, pass in basic effect dot current technique dot passes. So this will allow us to do all of that. We'll apply the pass. So that like sets all the parameters that are needed to like render that a specific pass in a specific technique. So now like all of the render settings are set up correctly as determined by the current technique for this particular pass. A lot of these don't have multiple passes, but this is kind of just a good paradigm to follow because now I can pick a different technique that has multiple passes and this code still works. And I don't know. That might be it. No, I know I'm missing something. I'm missing my matrix transforms. And let's see. Basic effect dot. I'm going to enable vertex color because I don't know if I specifically need that. But it does, like, it's reasonable to have that on there. But the things that I'm missing here are, I need to set up my transforms. So there are 3 matrix transforms. The world transform is basically like this will transform the points that are presumably in like object space. They're relative to the origin of the object and transform them to their correct location in the world, which is why it's called a world matrix. So imagine you have created a 3D model of a tree. Like you'll go into Blender or whatever and you'll like, create a cylinder and like make some leaves and whatever that is. And now you have all these points where like the base of the tree, like on the ground is like at 0, 0, 0, but like it goes up like, let's say 5 Blender units, 5 units, and we'll say that's meters. So now you have this little like pine tree that has these points that are generally centered around 0, 0, 0, but go up to like, let's say, well, maybe I'll just open up Blender here really quick. If I had Blender installed, I didn't have MonoGame installed. Okay, so the way Blender's working here is the x-axis is side to side, the y-axis is depth, and the up and down is z. So like, if you had something like this where you just said, let's see, I'm not trying to do anything too crazy here, but like, right, like this is going to be a really dumb. Anyway, very crude. That's awful. Don't judge me. I'm not an artist. But the point here is like these points up here are, I don't know, like just from reference, like these are like, I don't know, 5 or 8 units up or whatever. So like this is what you have, and the world transform is supposed to do the equivalent of like, this kind of thing. It's like, well, we'll just go place this in the world somewhere. So it does that where it takes the coordinates that are, something like, this, I know there's a way here to see. Yeah, so it takes coordinates that are like this. They're like 15, they're around the origin, move them out into the world where they should be for them to get rendered for this particular occurrence. In this case, we don't actually want to do anything, so we'll just use matrix.identity, which is a matrix transform that says do nothing, and then basic effect dot echo. Sorry, there's a comment in YouTube about got some bad echo going on there. What kind of echo? It's like I don't have a speaker. There's not, the audio is not coming out, so it's not like picking itself up. Is it just like room echo? We need to tweak audio settings. The next transform is the view transform, which this is about placing the camera in the world. So the easiest way to do it is there's a bunch of matrices in here that are specifically for this type of thing. This create look at is probably the main one. So this says, like, where do you want to look? Well, we want to look at 0. And, oh, sorry, that's the camera position. I actually always do that. Vector 3, new vector 3. So we want to place the camera, and let's say we put it 10, 10, 10. And then the target, so where is it looking, and then what is considered up for this. So if we say vector 3 dot unit z, then that should actually mirror like what we're seeing in Blender. Where the z-axis is up. So that's like a 10, what did I say, 10, 10, 10. That should get us a, actually kind of where this camera object right here is. Right, that's the camera, and it's something like 10, 10, 10. It's not quite 10, 10, 10. I think we need to be a little higher. Something like that. And then the last one we need is the projection matrix, which basically tells us what type of camera we have. And I'm going to keep this simple for the moment. So create perspective field of view. So a perspective camera is usually the most like natural looking. The field of view is like how wide we're looking at. Like if you had a telephoto lens, then the field of view is very narrow. If you have like a fisheye lens, which the way that the graphics card tends to do those transforms doesn't, like if you like doing fisheye would be, I'm sure there are people doing it. It isn't like whatever is going on there is probably not easy to do straight out of the box, because it like lines are not lines anymore with a fisheye lens. But the point is, if you have like a super wide angle, like the bigger this angle, the more you can see side to side. But something like a 45-degree angle is more typical. Though right now I'm trying to remember if this is it's just math.helper.2 radians. I think this is expecting radians, not degrees. The aspect ratio is the width to height, and and then just the way the graphics card works, like it eventually figures out how deep in the screen things are, and so it has to decide whether like how deep things are, so that it can decide whether the new pixel that we just computed should be hidden by what it's already drawn or not. And so it needs to know, these like, well, what's the closest thing you might ever draw to the camera, and what's the farthest you might ever draw to the camera. And you could just say like some very small, it must be greater than 0, but some very small value, and then some like massive value like float dot max value. But the problem is like that affects like the amount of like resolution you have. And if you just go really, really big, you start to get a lot of visual artifacts. So usually it's better to say, well, I'm 10, 10, 10 away from what I'm looking at. If I make this 50, that should work. Okay. And so other than like all this stuff is just piled here to draw, which I don't want. Theoretically, this should get me something that might look like what we're trying to go for here. So I'm going to run it. We'll see what we get. There'll probably be some troubleshooting. And then maybe we can address some of those things. Vertex. Oh, yes, I did forget something. Vertex buffer must be set before calling. So so it's related to the vertex buffer, but I'm going to put it like down here. We need to do graphics device dot set vertex buffer. So we need to tell it this is the data that you're supposed to use, and graphics device dot indices equals index buffer. So we need to say for what you're drawing right now, like this data we just made up here is what you're supposed to draw. Let's see if that works. It does look like it worked, other than, I guess I'm a little surprised like that. I would have thought the blue would be a little taller. Like given where we're at, 10, 10, 10, I would have thought that each of those lines would be about equal. And so it makes me want to double check some of this stuff. I guess I was hoping that it would. I can just look up the docs here. Let's double check some assumptions. So the field of view in the y direction in radians. And then, so it is radians. The y direction's up and down. In my head, I was thinking side to side, but so aspect ratio defines the view space width divided by height. So did I do that part right? Yes, I did do that part right. 45 seems okay. I was wondering if we had like truncated it. And you know, I mean, it could be that like I'm just looking at it at a higher angle than I was imagining. I just don't know if that's true. I'm gonna run that again. I guess even here. So the general concept does seem to be working. What might be nice is to make a camera that like could rotate. So if we do something like this, I'm going to private float camera angle equals 0, and then in update I'm going to just do camera angle plus equals gain time dot elapsed gain time dot total seconds times. So I'm going to basically, however much time has passed since the last update, I'm going to add okay. So basically I'm going to make it so that I multiply, so however much time has passed, I'm going to multiply that by 2 pi, which is a full circle. So I'm going to set this camera angle up to go completely all the way around every second, which is fast. But then down here, I can set up my view to be something like this. 10 times math dot cosine of the camera angle and 10 times math dot sine of the camera angle And I'm not going to explain that. It deserves to be explained. I'm not saying that you shouldn't. You should just know it or something. But I don't have time to get into it right now, so I'm going to skip it. But that's the idea. Is like I'm computing the x and y coordinate, the x and y coordinates based on that angle, which is, I mean, like that's it is. I'm going to call it this. That's basic trigonometry. Not that there's anything basic about trigonometry. So like that type of stuff is one of the first things you learn when you study trigonometry. But a lot of people haven't taken a trig class, and the ones that have, they forgot it all. Anyway, there's a whole other topic of like math through the lens of like being a game programmer or a graphics programmer. So like we're swirling around this. Everything there looks good. Other than I still feel like that the z-axis does not look as tall as I would have expected it to be. Like it looks to me like it's not. It's half the length, and I'm trying to figure out why that would be. Like this looks like it's correct. Does changing that make it look different? Yes. Now it looks too long. But it might just be that we need to just see this from other perspectives. Like maybe so I'm going to put in another angle. I'm going to put in a second angle that's like that vertical angle. And now I have to do even more trigonometry down here, because what I need this to be is times math f dot sine of that second angle that I've called phi times math f dot sine of camera angle, and then this times math f dot cosine of, I got that last part wrong. This should be phi as well. Kind of winging it here. Again, that's a fair bit of trig to throw at you. It is definitely spinning too fast. Let's slow that down. Actually, and I could set that up so that it is controlled by the keyboard. I'm not going to have time to do that. I don't know. Like I still feel like that doesn't look like the right length. But I'm about to run out of time. Is there... am I getting too close to it? Is that the issue? Should I, like, what if I move? well, for one, what I should do is, so I'm 10 units away. I do so this is really kind of weird, complex stuff. Like like I said, it's if you've done a lot of like trig or a lot of graphics programming, like you won't be too surprised by that. So this is X, Y, and Z. Like you will have basically seen these in equation form before, but if you're new to it, like it's definitely something else. So don't feel overwhelmed by it, because it honestly just is kind of overwhelming. All right, so with this now, I'm basically just saying compute the angle as like a unit vector. It'll be one unit away from what I'm doing, and then just move it out to 10 units. So now I can move it a little farther away by just changing one number. So we go like up and over the top and then back down the other side, and it kind of like flips around when it does that. It's interesting that it really doesn't. Well, one thing we could do here is we could say I'm just going to reset those. So that should, yeah, I don't know what I expected. From this angle where it's like 45 degrees, I really would have expected that blue line to be about the exact same length as the others. All right, I'm gonna have to end this here, but I might come back to this next weekend. This might be an interesting place to keep exploring. I mean, there's a lot that we can do here, including we should not just be making these every single time. So maybe in the meantime, I'll have some thoughts on like maybe it'll occur to me why we're getting what looks like a shorter line in the Z direction. Okay, wait, I just had one more thought that I want to do, and that is what if I make let's make Y be the up direction. And does that make yeah. Let's try an orthographic projection really quick here. I'm doing something wrong. I don't know what it is, and I don't have time to figure it out right now. So we're going to have to leave the video this way. If you have any theories on what it is. Oh, wait. Let me. I know exactly what it is, But if you can figure it out, then post it in Discord or on the YouTube comments. I'll tell you if you're right. No, I'm kidding. I don't know what it is. But if you have any ideas. So there's probably something really small that I'm missing here. Like, I think the general strategy is right, but I'm probably doing something weird or dumb. Anyway, I think there's a lot more that we could do here, including clean it up so we're not creating all this crap every single time through. So that would be an interesting thing to do next time. Figuring out what's going on with this bug would be an interesting thing to do next time. I did want to talk about this perspective versus orthographic projection. I kind of just threw that in there. Maybe we'll talk about that a little more next time. Anyway, so no promises, but I might come back to this in a week. We'll see. But I'm gonna wrap this up for right now. So anyway, I like doing this. It's fun. Like I said, it's just a casual like programming session. There's not like, it's fun to work on stuff where there's like no stakes. You know, we didn't figure this out. Oh well. It's not like, oh no, now we can't ship the feature. We can't whatever it is. Like it's working on low stake stuff is interesting. So, and I've enjoyed doing them. It hasn't been every week, but it's been a lot of the last maybe 6 weeks. So maybe we'll do this again next time. If there's audio issues, I apologize. Maybe somebody who knows how to mess with these settings, maybe I can work with them to sort it out. So at least this time there's some sort of audio, unlike last time. All right. I'm calling it here. So, but thanks for your time. It's been fun, and I'll see you next time.